All right. Hello, everyone. So we are back for once again. I've said this a couple of times. I'm going to try to fulfill it today. We're going to try to get through as much of chemistry as possible. Obviously, aim aim for the stars, shoot for the moon, you know what I'm saying? Um, we're going to try to get as far as we can on chemistry, get this basic chemistry out of the way. Like, we don't need to be doing this for a million years. We have 6 chapters left. Each one of these has about like, I don't know. Well, some of them have like pretty much, they're all like pretty different lengths, but um, like within a certain range. But I really want to get this chemistry stuff out of the way and not worry about it. There's also another way for me to like catch up. And just get like all this, like, I don't really want to, like, I realized I did want to get biology out of the way, but biology is just always going to be a slower pace thing. By getting chemistry out of the way, we can, like, I can do like my practice test and um I don't know, feel a little more confident having at least one of the sections entirely like the basic ground knowledge. Having all that learned is just definitely going to make me more confident going in. um and yeah, I think first, before we do that, I want to go into the browse, so we can just kind of take a look. Maybe, I'm not sure if, I feel like I might have looked at the cards already. So, um, uh, I don't think equilibrium is actually gonna be one that we need to like really look at that much. What we might need to look through is thermochemistry, but once again, not really sure. Uh, this is gonna be one of the only days that instead of starting with by clicking on one of these titles, we're just gonna start on the bigger one. Because I'm sure maybe you guys have realized, okay, my stick drift is really pissing me off. Um, so instead of, oh, I'm gonna put my reviews to 0. I'm not really even trying to think about that right now. Um, so yeah, so we're just gonna start off by just clicking the title. That's gonna help us to uh, like, when we do the cards, it always has this like problem. If it's too low of an amount of cards, obviously, by the time that you run through all the cards that you had just seen and have just recently gone into review, they're not going to get the full 10 minutes. So hopefully we can try to get around that as much as possible by just clicking the title. Um, and yeah, we're pretty much just going to try to do this for as long as possible. Once we realize we've gotten to a point that a lot of the cards are starting to get more difficult, we can go into browse, just look through the cards, familiarize ourselves, and yeah. So, uh, browse. Oh no, not browse. Sorry. Chemistry. All right, let's do it, guys. We're gonna. If we do, let's do a bit of math before we do this. So we have, if we click here, we have, this is worth 5%. So it's, we would get through 5% of the deck if we were able to do it all today. I don't think, maybe, I know what, sometimes you just have to walk in with faith, bro. So let's do it. think our audio should be back. Uh, I don't know what happened. I don't know when my audio cut out either, unfortunately. Um, and then audio capture. Okay. All right. We should be good again. Hopefully, hopefully that doesn't happen again without me realizing. I don't know how long I was gone, obviously. I'll put that over there. Okay, cool. Um, all right. So, a reversal reaction is a reaction that establishes an equilibrium between the amount of products and the amount of reactants. What is an irreversible reaction? It means that the reaction runs to completion, so all of the products are formed, um, like given the amount of reactants that you have. What are the two types of dynamic and static? What is a static equilibrium? A static equilibrium is um, a static equilibrium. Um, uh, Damn. A static equilibrium. Hold up. Actually, give me 1 second. I do want to be able to see this. Okay. All right. All right. Um. So damn. I kind of need to do this too. Okay. So, what am I like? Okay. Yeah. So, um, so a static equilibrium is, I don't remember. Reaction is at equilibrium because neither the forward nor reverse reaction occur at all. I think here the reverse reaction is equal to the forward reaction. So, uh, so the amount of reactants and products is stable. That was correct. It's equal to 0. What is an equilibrium expression? Um, Way to calculate the concentration of products and reactants at equilibrium. How do we write an equilibrium expression given the balanced equation? Um, it would be like concentration of C to the C power um, times the concentration of D to the D power divided by B, so on and so forth. What is a static equilibrium? It means that neither the forward nor reverse reaction is occurring. So the reaction is at an equilibrium. What kind what kinds of products and what kinds of reactants, solids and liquids, they need to be aqueous. Okay. I didn't say other than water, so is the equilibrium constant a constant? Um for a given reaction, yeah. Okay. What is an equilibrium expression? Um, Way to calculate the concentrations of products and reactants. If the equilibrium constant for a reaction is written in one direction is KQ, what is the equilibrium constant of the reverse reaction? KQR. If the so it's basically just saying the reciprocal. Okay. As KQ increases, the amount of okay, yo. So for anyone that's watching this in the future, I just want everyone to know that this is my friend in the chat. Um, are you just gonna like join like every time and just say that it's empty, buddy? Um, uh, as KQ increases, um, the amount of products or reactants at equilibrium increases. Um, I think as KQ would increase, I'm assuming the number of products would increase too, right? Right? Yes, sir. What kinds of reactants and products do not appear in the equilibrium expression? Um, what kinds of so they could be solids or liquid excluding water. Is it no, it depends on the reaction and the temperature. What is an equilibrium expression? I'm just pressing hard right now because I don't wanna, even though I'm kind of getting them right, I don't I low-key don't like the intervals that that it gives sometimes. So I don't want it to like explode and it'd be like because it's of the understanding that if I press good on something too early in the reviews, it pops up for me 7 days later, which is which is a little too much. I'm not 7 days is ridiculous for some of these things. It's not gonna take me 7 days, bro, before I forget. What is an equilibrium expression? Yo, it has asked me this a million times and I still can't get it right. Way to something about the products and reactants. Way to calculate the concentration of products and reactants at equilibrium. Equilibrium. I don't know, bro. Equilibrium is just a funner way to say it, bro. I don't know what to say. If the equilibrium constant for a reaction written in one direction is KQ, what is the equilibrium constant of the reverse reaction, the reciprocal? Um, Dynamic and static. What is a reversible reaction? A reversible reaction is a reaction for which um there is a ratio of um but like once it hits equilibrium, there is a ratio of products and reactants as opposed to having all of the reactants just turn into product, or well, as much of the reactant as possible turn into product. Reaction will start equilibrium in existence some combination of products and reactants. I don't know. I don't know what's going on. Sometimes my alarm rings and then it's just gonna like it's gonna mess up the whole thing. 1 second. Um. All right. Okay. Let me get the. Okay. There we go. Reaction that will establish an equilibrium and exist in some combination of products and reactants. Um. That's kind of what I said. It exists in like some kind of ratio. What is an irreversible reaction? This is just the reaction. There's no like equilibrium per se. It's just kind of it shifts from all like reactants to as many products as can be made. What is an equilibrium expression? Um, yo, this one is stumping me for some reason. I'm gonna need to stare at it for a second, bro. Way to calculate the concentration of products and reactants at equilibrium. Okay, maybe if I think about the expression itself. So we would be establishing Kc is going to be equal to product over, or the concentration of product, which are multiplied by one another, by concentration of reactant, whatever. All right. So this is a way to calculate the amount of products and reactants present at equilibrium. Okay. All right. Try this again. What is a dynamic equilibrium? Uh, it means that it establishes some kind of the forward and reverse reactions are both occurring in order to establish a ratio or some combination of reactants and products. Uh, yeah. I don't really want to give myself that. I'm gonna say 0. It's just gonna be c to the c power times d to the d power divided by a to the a power, so on and so forth. Is no, it depends on the reaction um, and the temperature. What kinds of reactants and products do not appear in the equilibrium expression? Um, Guys, I have great news. So far, right now, we are on track to finish all 250 of these cards by 2 o'clock tomorrow. Isn't that fun, guys? What kinds of reactants and products do not appear? Solids and liquids, except for water. As KQ increases, the amount of products increases. What is an equilibrium expression? An equilibrium expression is a way to calculate the amount of, or the concentration of products and reactants present at equilibrium. All right, first time getting it right. What is a dynamic equilibrium? It means that the forward and reverse reactions are equal, so there's no change in products or reactants. How do you solve for the concentration of products for a reaction given an equilibrium expression? Well, if you have the equilibrium expression, I mean, it depends. You would need the concentration of something. You're just realistically, you're isolating. Oh, this is the ice table, right? I think this is the ice table. Hold up. Um, uh, um, let me look it up. I feel like this tutorial isn't the best. So one second. Um, okay, so basically what I learned is this applies if this situation is only gonna apply if you have zero of both of the products, right? So if you have zero of both of the products, then you can kind of assume that it's gonna go forward. Um, I would obviously prefer uh, to have like to just kind of use the ice table. I feel like it might be easier. Let me see if I can find one where it's it's like easier to figure out. Um, let me. I'm gonna get the screenshot. Let me get the screenshot in there. Um, I'm gonna leave. I'm gonna leave what they have there. Um, but I just want to. Okay. Um, this problem took a while. Uh, okay. It's a little better. Um, okay. There we go. This is that's the source. In case anyone was wondering. Um, I'm not trying to get like copyright striked or something for a website screenshot. So uh yeah, so this is what I was saying. So in this problem they were given all of the they were given the constant like the amounts of all of the like parts of the reaction. So they put that down as the initial concentration. Obviously they calculated the concentration with the moles and liters. Change in concentration, you just mark it down with X according to which direction it proceeds in. And I'm sure that the deck is literally about to teach that, like right now, how to find the equilibrium quotient or whatever, or the reaction quotient. Uh, and then the equilibrium concentration is just gonna be like it's just gonna be these expressed as like one singular expression, and then you put that down in the equilibrium expression that we spoke about earlier. So I'm also going to copy the rules. Um, So it should only be dropped like here. Um, so here the equilibrium concentration is gonna be 0.0076, and then the initial concentration is gonna be the initial concentration of the reactant is zero point 0.6. So the case is said if KQ is more than 2 orders of magnitude less. So divided by 10, divided by divided by 10. It's not exactly, to be honest with you. But to be honest, in a case like this, I feel like it might be worth just doing the estimation. So let's genuinely try this problem real quick. So they kind of already did the other work, but let's just try this out. So if we did all of this, right? And that's the problem. It does have that two. It has that two as well. Okay, we're just gonna see. Let's just test it out. Let's just drop the whole 2x. Let's drop it completely, right? And we'll just leave 0.6 squared. Let's see what we get. Um if I put it on Desmos, um 0 0.400 minus x. Why does it keep doing this? Okay. All right. That's really strange. Just disconnected my headphones for no reason. Uh, um, what? Oh, that's the bottom of it somehow. Okay. Uh, okay. Um, Hi, buddy. What's going on? So, all right, my fault. Um, Now let me see. Is equal to 0.0076. It should give me, okay, it gives me two options. First one is going to be either 0.022463. Damn, it low key is far off. If I would have put, if I would have put the plus 2x, then now we get the 0.216. Um, it did give two solutions though. So I don't know. That's not. I hope that they don't give anything like that on the MCAT because that would definitely suck. Um. All right. So, but I feel like we understand how to do it. Which is good. How do you solve for the concentration of products? All right. Yeah. I think we're good. I just need to like think about this process. Um. Again, if the equilibrium constant for for a reaction is written in one direction, it's going to be the inverse. Um, okay, so static equilibrium, the reverse and the forward and reverse reactions don't occur at all. So it's like um, there's just like a stable amount of reactant and product. And I don't want to push that to tomorrow yet. What is a reversible reaction? A reversible reaction is a reaction that um like for which there's a forward and reverse reaction, and that results in a combination of products and reactants in a specific ratio. Is equivalent? No, it depends on the temperature and the reaction. What is a dynamic equilibrium? A dynamic equilibrium is um, it means that the forward and reverse reactions are both occurring. Uh, are both occurring at the same like rate, so there's no net change in number and like reactants and products. What is an equilibrium expression? It's a way to calculate the concentration of products and reactants. Um, Way to concentrate the concentration of products and reactants. It's gonna be products over reactants is equal to Kc. Oh, I didn't even say at equilibrium, bruh. Static and dynamic. What is an irreversible reaction? It means that the reaction goes to completion. There's no, there's no like reverse. Like there's only the forward reaction. As KQ increases, the amount of products increases. Damn, bro. You see, this is what I be saying. What do you mean 8 days? 8 days? 8 days? No, bro. We're not accepting no 8 days, bro. Zero. You see, like the one that I didn't regulate, the one that I wasn't consciously regulating, brought it up to 8 days. But that's what I'm saying, bro. That's ridiculous. 8 days? No, that's OD. This one too, bro. Okay, I'm actually gonna leave that one alone because I think I could actually remember that one. 8 days from now, I think I'll still remember it. What kinds of reactants and products do not appear in the equilibrium expression? Um, Solids and liquids except for water. How do you solve for the concentration of products for a reaction given an equilibrium expression? How do you solve for the concentration of products for a reaction? You would need to use the use the equilibrium expression. If you have A as being turned into B and C, right? You would form an ice table with A, B, and C. You're gonna do the initial concentration, the change in concentration, and the equilibrium concentration, right? Ice. And then you're gonna have uh I feel like it was always so cool to be able to draw these. Hold up. I just want to try one more. Wow, oh my god. So, anyways, so if they tell you, oh, this is 0.5, um, this is 0.5 molar, and you know that you have zero of this and zero of this. Okay, so you know that it's gonna go this direction. So we're gonna go minus x based on the coefficients, minus x and plus x, right? So this is gonna be 0.5 minus x. There's just gonna be x. It's just gonna be x. You're gonna go kc is equal to x squared over 0.5 minus x. And if the kc is like, if the kc is less, is greater than 100 times less the initial reactant concentration, then you can just remove this x. It's just gonna be like, well, that's like irrelevant. Um, so yeah. Otherwise, if they give you either one of these, then if they give you the concentration for either one of those, then you would need to calculate the reaction quotient first to determine which direction it's going to go in, and then you can do this like whole process, and you would know whether to subtract or add for the change in concentration. What is an equilibrium expression? Equilibrium expression is a way to calculate the concentration of products and reactants at equilibrium. What is a reversible reaction? It means that it has a forward and reverse reaction that establishes an equilibrium at a specific combination of products and reactants. Um, what is a dynamic equilibrium? A dynamic equilibrium is, I don't know, guys. The rate at which I'm moving through these cards is not looking too high. I'm gonna be honest with you, but hey, man, we're still trying. We're trying. That's what matters at the end of the day. We may be 55 minutes in, but we just gotta hope that no more of those process cards show up, because the process cards are what really slowed us down there. That was probably like 10 minutes worth of time. What is a dynamic equilibrium? A dynamic equilibrium is when there's both a forward and reverse reaction that are occurring at the same rate, so there's no net change in the products and reactants. If the equilibrium constant for a reaction written in one direction is KQ, what is the equilibrium constant the reciprocal? What is a reaction quotient? It marks your progress toward reaching equilibrium, realistically. It doesn't, the equilibrium constant is determined by putting the products at equilibrium, um, and the products at equilibrium and dividing it by the concentration of the reactants at equilibrium. However, the reaction quotient it's the current state. So you would take the current place, the current uh we're gonna work this out. We're gonna work part of this out now. So if we know that it's okay, all right, stick drift. Um, if we know that we're gonna have the products on top and the reactants on bottom. I'm not even gonna bother doing writing out react. Um, the only way for this to get bigger, and this technically does apply to equilibrium and reaction quotient because I'm not specifying what the time of the product or reactant. But the only way for this to increase is for either this to be bigger or this to be smaller. Small and big. Okay, so that would make this larger. So if the current Q is less than K, or actually let's start with greater. If the current Q is greater than K, then that means that could mean that you either have more products or less reactants, but those issues are one and the same. Even though they seem separate, they're one and the same because having more products, because this is a comparison, having more products would just mean that in a reaction uh where it goes A to B, right? More products would mean you shift this way via like more products would mean, because it's a comparison, more products would mean you're shifting toward A, right? If the Q is bigger, the Q, not the K, we don't go with reference to K. I guess we could, but I feel like this is easier to just go with reference to Q. If you have too little reactants, like it still doesn't matter. It would still mean that it's still shifting that way. So, and that's realistically the goal of comparing the reaction quotient to the equilibrium constant. Um, that allows you to just see which direction the reaction is going. And obviously, if K is equal to Q, then it's obviously at equilibrium. Yeah, I feel like we have an understanding of this. I'm gonna click hard because I don't want it to tell me I have eight. It's gonna show up in 8 days. What is what is a static equilibrium? A static equilibrium means that the forward and reverse reaction aren't occurring at all. So there's just a stable amount of reactants and products. Is the equilibrium constant a constant? The equilibrium constant is not a constant because it's specific to the reaction and the temperature. How do you solve for the concentration of products? You're going to use the ice table. So you're going to put the initial concentrations that they give you. You're going to put the change in concentrations based on the coefficient. So if it has a coefficient of 1, you would just do minus or plus x, depending on the direction of the reaction. And then for E, you're just going to basically sum those up. Um, It obviously could be subtraction too because it's minus, but you're not subtract. Like if you have minus x in the change column, you're not going to do minus this. It's technically plus. So yeah, I just want to make sure that's clear. So uh, yeah, and then you basically just solve. If your k if the KC that they give you is 100 times like smaller than the initial concentration of the reactants, then you can, and like in the re- in the change column, like or in the reactants portion of the equilibrium expression, you have you have minus x, the initial concentration minus x, instead of like multiplied or something like that. Then you can just like remove it. You can just delete the x. Um, I think the biggest thing is where I could see that like explanation going wrong is if they ask about two, like two of them, there I might be screwed. But hopefully there's an answer that's like simple, like I don't know, it's more easily correlatable to one of the answer choices. Um, the products increase. In what direction will, if Q is less than K, um, if Q is less than K, then it's gonna shift toward product, shift to the right. Yeah, toward product. I do like that diagram. That diagram is kind of cool. If I could think of like a mechanism to remember that, um, remember how they used to say that the alligator eats the bigger number? What if I said that the reaction quotient chases after the alligator? Um, maybe that'll work. Uh, like I was right, so I don't wanna. In what direction will the reaction proceed? It's gonna proceed. It's gonna go to the left. As long as I remember that Q always goes first, or as long as I always like organize it according to Q. Uh, if I can't remember to do that, then I'm obviously gonna get it wrong, which might make it a faulty mechanism. But I'm gonna go for it. In what direction will the reaction proceed if Q it's at equilibrium already? So what is Le Chatelier's principle? Le Chatelier's principle says that the reaction will compensate for changes. So if you have a reaction that is at equilibrium and you put in more product, it's going to shift toward the reactants. If it's at equilibrium and you add more reactant, then it's going to shift toward the product. Um, yeah. How do reactions respond to changes in pressure and volume as described by Le Chatelier's principle? Um, I mean, I guess if you decrease the volume, then obviously, if you decrease the volume, then fundamentally in the gaseous system, then you would also be increasing the pressure. Um, so it would shift toward the reactants in order to reach the same previous pressure, or it's going to shift toward the side that has less products, not necessarily toward products, but like it's going to shift toward the side that has like less moles of product or of I don't know, substances. Yeah, that's literally what I said. It's gonna in the case of this specific reaction, it's always gonna shift to the left. It's gonna shift to the left if wait, what? Oh no no. Yeah, I was right. It's gonna shift to the right if you increase pressure or volume. It's the same, it's gonna have the same effect. decreasing volume and increasing pressure, it's gonna have the same effect. Oh, bro, it literally also says that right there. Okay. Um, what is a reversible reaction? Oh my god, 11:31. Wow, that is phenomenal. Only like 18 hours or something left. But hey, man, that's better than before. What is a reversible reaction? A reversible reaction. How far, bro? How far are we in this? How many more like cards? How many new cards do we have left in this one? We have like seven new cards. Seven new cards remaining. What is a reversible reaction? Um, a reversible reaction. Uh, we didn't even have that. It wasn't even that many cards in this one. I don't think it was 26 cards. What is a reversible reaction? It has an equilibrium in which there is a specific combination of products and reactants. What is an equilibrium expression? Uh, it's the way to calculate the concentrations of reactants and products at equilibrium. Le Chatelier's principle says that equilibrium is going to shift in order to resist changes in the system. What is the reaction quotient? It marks the progress into the reaction. You can compare it to the is that wait, what does that say? Uh, that's weird. It's saying I have a low bit rate. I don't think I have a low bit rate. I've had this bit rate like the whole time, like forever. So that is a little strange. Okay. I don't know. I'm just gonna pretend. I'm gonna pretend like I didn't see that. I don't think I've ever had a different bit rate than that. Yeah, so it just marks your progress. You can compare it to the equilibrium constant in order to determine how far you are from equilibrium or in what direction the reaction is going to go. Um, bro, I just got the warning again. Uh, is a higher? Oh, now it's good again. Okay, it's saying it's good now, but I literally there was no change in bit rate at all. Okay, that's so strange. Okay, so all right. What is a dynamic equilibrium? Dynamic equilibrium means that there is a reverse and forward reaction that are proceeding at the same rate. So the change in the net change in products and reactants is there is no change. And Sorry, guys. Give me 1 second. Okay. All right. In what direction will the reaction proceed? Yeah, I don't think we're like. I think we're probably gonna stop around like 10. Like around like 10 is when we're probably gonna stop. Um, or maybe 9. I'm not sure. It's gonna be probably like 3 hours, like 3 hours stream. Okay. Before I continue though, I do need to use the bathroom. So give me 1 second, guys. All right, we're back. Uh, in what direction will man? What direction will the reaction proceed if Q is less than K? So it's gonna follow since it's following the alligator. We know that it's gonna move to the right. In what direction it's gonna move to the left? To the left. To the right. Take it back now, y'all. I don't know how many hops this time. I'll be honest with you. Okay, cool. How do reaction response to changes? It's gonna cause it's gonna shift in the direction where there's less moles of gas. What is the Chatelier's principle? That's gonna be the equilibrium is gonna shift so as to resist changes in the system. How do you solve for the concentration of product for a reaction given an equilibrium expression? Um, you're going to use that expression as well as its coefficients in order to put uh, hmm, uh, the initial concentration is going to be the concentration they give you, depending on if they give you the products or not, or the concentration of the products or not. If there's no products at all, then obviously you would put zero for the initial concentrations of those. Then you would put in the change in concentration column or row, you would put you'd put minus or plus x depending on the direction that it's going. You could use the q to determine that, or yeah, I think you could just use the q to determine that. Um, then what's it called? Uh, then how do you solve for the concentration of products for a reaction given an equilibrium expression? Um, and then you just put it into the equilibrium expression and then put the QC in. If the QC is like 100 times less than the initial concentration of the reactant, then you're gonna have you can just eliminate the X from the denominator. And with the it's gonna stay the same. The reaction is already at equilibrium. I knew that, so I'm not even gonna bother trying to reduce those 8 days. What is the reaction quotient? The reaction quotient is it marks the progress in the current reaction. What side of the reaction is the heat on in an endothermic reaction? Um, that's gonna be on the reactant side. That's easy. On the product side. How do reactions respond to changes in temperature? Um, well, I think so. Changes in temperature are also going to result in changes in an increase in pressure. So it's also gonna shift to the side that has less moles. I'm pretty sure. Oh, damn. Okay, I did not take this into account. Of the two, which is made faster, the kinetic product or the thermodynamic product? The kinetic, I think. In a reaction with two possible products, how do you get the kinetic product? Uh, I don't know. Apply the lower temperature to the reaction. Is this accurate? Um, 1 second. Favors reaction with. Okay, so now if I try checking this card, then what? Oh, favors product. How do reactions respond to changes in temperature? Well, if it's endothermic, then it's going to favor forming the product. If it's exothermic, then it's going to favor forming reactant. Of the two, kinetic product is made faster. In what direction will it proceed? It's going to proceed to the right. Of the two, which is more stable, the thermodynamic product. In a reaction with two possible products, how do you get the thermodynamic product? Um, you get the thermodynamic product by applying a higher temperature. Okay. In a reaction with two possible products, how do you get the kinetic product? With two possible products, how do you get the kinetic product? Maybe we could get to like 100, like 100 cards before 9. It's not looking good right now, but maybe. I hope so. In a reaction with two possible products, how do you get the kinetic product? Um, Wait, what did I just say? We're at 274, so we've done 26. Okay. In a reaction with two possible products, how do you get the kinetic product? You just need to apply a lower temperature. Give the value. This is gonna be 0. Like I think there's gonna be a guess of doom. 0. 0.8. I think 83. No, 0.083576. Oh man, damn. That was really far off, which is kind of embarrassing because I literally like. Why is this a completely different value? Am I bugging? Why is this not the same? Am I? Hello? What? Why are the numbers switched? I think it's this one, but why did they include gas constant? Bruh. Oh my god, bro. Gas constant value. So, oh, someone else found that. Someone else realized, which is good. Yeah, the first picture is just wrong. Um, just gonna. How do I crop this? 0.082 mole times Kelvin. Okay, all right. because I think we did the gas constant value for the equation set, and maybe usually whenever I forget something, it just so happens to pop up in my reviews, like sometimes soon after that. So it's probably gonna pop. That probably means it's gonna pop up for me soon, and then I'm gonna have to click again because I just learned it. How do reactions respond to changes in pressure and volume? It's gonna shift toward the side with less moles. The density of water is it depends on the unit. I think it's like 1 gram per centimeter cubed, something like that. Yeah, I need to remember that centimeter cubed is also equal to a milliliter, which would help me to get to this and also this realistically. I feel like if I know this, then I should be able to get the rest. In what direction? It's gonna move, shift to the right. Give the value of the gas constant, 8.314 joules per mole. Uh, this it's just wrong, bro. I literally added times Kelvin, and it just joules per mole Kelvin, and then 0.0821 um, ATM liters divided by mole Kelvin. Um, in what direction it's going to proceed to the left? Of the two, which is made faster, kinetic? What is this? It means that the system is going to shift toward the direction that causes the least change. Like it's going to shift in order to resist change to the system. How do reactions respond to changes in temperature? Um, how do reactions respond to changes in temperature as described by Le Chatelier's principle? Um, am I tripping? Did I click on the wrong thing? Yes, I did. Man, I clicked on the whole deck. It started giving me questions from essential equations, bruh. Now I gotta figure out which ones those are. What are these? Can I want to reset these reviews. The density of water. I don't want to. Okay, you know what? I'm gonna leave those. I don't know. Do I even leave? Do I leave those? Okay, look, right. This is what we're gonna do. What's the other one? Density of water is 1 gram per centimeter cubed. Yes. I don't want to do any new cards, but I just want to see what the other one is. Zero, zero, and then let's see. What is the other one? The value of the gas constant. Okay, so that's why I could have sworn this was in the other one. Um, value of the gas constant. Okay, all right. So it's gonna be 8.314. Yeah, we're just gonna good. And the density of water is 1 gram per centimeter cubed, and 8.314 joules per Kelvin mole, and um and 0.0821 um ATM liters divided by moles Kelvin. Okay, so what we're gonna do this quickly, where we are actually only gonna do 5 minutes here. All right, let's see. We're gonna go mini. We're gonna do the mini crossword, where we never take more than 5 minutes to do the mini crossword. So this should be easy. We have we normally don't we normally don't take that long on that. So like usually it takes like 2 to 3 minutes. So that's what I'm expecting this time. Um, mini. We're just doing this in order, like, number one, to get our mindset back, but also we're trying to, um, we're trying to stall so that by the time that we come back, it's been a couple minutes, and maybe low key, we should do two things so that when we come back, the 10 minutes have been stalled and it'll actually be valid. Um, all right. Works opposite. Laziness. I don't know. I don't know what this one was. Stack on the nightstand, books. Tree or cobra in positions, spur animals, I don't know. Not that many. A few. Measure of alcohol ends in an F. Maybe that's wrong. Check puzzle. No, I'm right. Measure um feeling relaxed. Slightly crooked. Oh, askew. Rarely true response to have you read are yes. Um, what? Blank free? Uh, uh, um, what is this? I don't think I've seen this on the ever. I don't think I've seen this on a water bottle. What is that? Glass and taste flower. Uh, I don't know, bro. Works opposite. I don't know. Feeling relaxed. Okay, I'm gonna reveal this square. Works opposite play. Um, what is this? What? I still don't know this. A rose? Are you serious? Pro measure of alcoholic content. Like, okay, let me just try to get the rest. Feeling relaxed. Lo- oh, loose, bruh. tree or cobra. Oppose. Are you serious? Okay. Then we could do the Wordle. Um, let's start with with a weird word. Let's do pros. Oh, okay. All right, I guess. Um, uh, L. I know I repeated letters there, but X. I'm gonna say L X X E. What if I did something like this? Damn. Embarrassing. Damn. Where the hell is this L? See what I did there? Um, up there. The L. Oh, maybe it could be like it's probably this. Um, I would say aisle, but the S is already taken, and there's no I either. Okay, so we're missing an A, so A. Um, ooh, let's go for a whale. Oh man, that's still wrong. L is definitely not that. X. So we know the L is there. ALX. It could be a valve. Okay. All right. I don't know how long it's been. We didn't take that long on this. We're literally gonna try speedrunning it. We're not gonna spend a million years trying to figure out this puzzle. So, cork, uh, staple, chalk, screw, nail. Screw, nail, uh, white, vanilla, pearl, and basic. Oh, chalk. I could do chalk. Not even one off. I thought I was like going for like what possible names for a shade of white would be. Uh, um, white, black. Uh, I don't know, bro. A nugget, gem, pearl, and a staple. Mm, one away. I think it's nugget. I think nugget is the problem. A staple, a pearl, a gem, and a This is the best that I think I can come up with, bro. Maybe a staple. I'm gonna go with staple. Damn, what was it? There's no way that that wasn't one of them, bro. Oh, damn, it was mid. Damn, I could have gotten that. That sucks. I actually could have gotten that. I had two different. I had blue and blue. I had these two. Word. A word is a unit of wisdom. How, oh, bro? That was impossible. Okay. Uh, um. Okay. So let me get. Let me put this back over to Anki. Okay. Give the value of the gas constant. So it's 8.31 joules per mole Kelvin and 0.0821 um, ATM liters per mole Kelvin. All right, perfect. Now we can go back to what we were doing. Put this back to 300. All right, so did I? Let me make sure I clicked on the right one this time. But I don't think I did. Again, how do reactions respond to changes in temperature? Changes in temperature. If it's an endothermic reaction, it's going to shift toward product. Exothermic, then a shift toward reactant. In a reaction with two possible products, how do you get the thermodynamic? You have to give a higher, like use a higher temperature. Of the two, which is more stable? Kinetic, thermodynamic is more stable. What side of the reaction is heat on in an endothermic reaction? The reactant. Apply a lower temperature. It's on the product side. In what direction will the reaction proceed if Q is less than K? It's going to proceed toward the right. The kinetic product. What are the standard conditions for measuring equilibrium kinetics and thermodynamics? Um, is it just talking about what STP is, or? Oh, yeah, it is. Okay. What is a substance's standard state? The state that it exists in at STP. Nice. Um, what does it mean if a thermodynamic property is written with a degree? It means that that thermodynamic property is like that is the value that that property exists at STP. What is STP? Um, those are just like the numbers that we use for like measuring all things in order to keep things like constant, keep our measurements constant. Um, I'm gonna change this. Wait, what? Oh, STP. STP is different from standard conditions. Oh, okay. I was okay about to suspend that. I'm not gonna lie to you. So it's 298 Kelvin, 25 degrees Celsius. Then it's still one ATM, and then there's one more, 1 molar. Okay. What is a spontaneous reaction? A spontaneous reaction is, um, bro, didn't we cover this already? It's a reaction that occurs spontaneously, bro. It has a delta G value that's negative. I don't think there's anything else really. I think that's exactly what I just said. How does the spontaneity of a reaction relate to its speed? Well, if it's not spontaneous, it won't happen. It's oh, sorry. Said that with a little too much confidence, I guess. What is standard temperature and pressure? 273 Kelvin and 1 atm. What are standard conditions? It's going to be 298 Kelvin, 25 degrees Celsius, 1 molar, and 1 atm. What is reaction coupling? Uh, what is a phase change? I don't really know. I don't know how much simpler that term can get. I'm not memorizing that. Suspend. In an isolated system, describe the phases of the molecules. I don't know what it. What is the difference between evaporation and boiling? Um, uh, is there a difference? Um, and like the only plausible thing, I think, so it's probably gonna show the phase change thing. So if I had to guess, it would be, I don't know, maybe this would be boiling, and then this would be evaporation or something like that. Evaporation is the natural conversion of liquid to gas due to equilibrium between phases, bubbling of the entire liquid and release of gas molecules once exceeding the boiling temperature. I'm gonna try to check this card because I don't know, man. Okay, so let me change these definitions because they're not quite. Um, How does the spontaneity? It doesn't. Thermodynamics and kinetics are different. They're separate. It's pairing one reaction with another in order to make the overall reaction spontaneous. In an isolated system, so there's just an equilibrium between all three of the phases. What is a substance's standard state? Um, what is a substance's standard state? Um, mm, what is a substance's standard state? Um, oh, that's just the state that it's in standard conditions, bro. What does it mean if a thermodynamic property? It means that that's the value of the property at standard conditions, in standard conditions. What is the difference between evaporation and boiling? Evaporation is like a surface level, like natural conversion from liquid to gas. It only happens at the surface level. Boiling happens to the entire fluid. It causes bubbles. Um, and it definitely is boiling point dependent as opposed to evaporation. What is vapor pressure? Vapor pressure is it's like the pressure that forms. Uh, this is like a part of the like equilibrium between the three phases. Um, so uh, like if you're heating up water, right, and you keep the heat constant and like you're boiling it, there's a certain maximum to the amount of vapor that can exist of the water and the amount of obviously water. So it's which is going to be equal to, I don't even know. I don't know if there's an exact number, but let me check this just to make sure. Okay. This is just a better way to put it, but I feel like this answer is sufficient for me to understand that. Um, what is standard temperature and pressure? Um, Standard temperature and pressure is 298 Kelvin and no 273 Kelvin and 1 ATP. What are the standard conditions? 298 Kelvin or 25 degrees Celsius, 1 ATP, and 1 molar. Of the two, which is more stable, thermodynamic? In reaction with two possible products, lower temperature. Well, you're gonna get use a higher temperature. How do reactions respond to changes in temperature? If it's endothermic, it's gonna form more product. Exothermic is gonna form more reactant. As temperature increases, vapor pressure also increases. I think I could get that in my sleep. What happens when the vapor pressure of a liquid is equal to? Sometimes you guys probably hear. I like to put like I put the controller like near my head sometimes, so you guys sometimes might hear it a lot more when I click the buttons. You guys probably get in like an ASMR of some sort sometimes. What happens when the vapor pressure? Also, I don't know if I mentioned this, but sometimes you see me do like this, like I'm moving like this. I hope that's not. I hope that's not too annoying. Uh, that's pretty much me, like swinging in my like chair. Uh, what happens when the vapor pressure of a liquid is equal to external pressure? Um, when the vapor pressure of a liquid is equal to the external pressure on the liquid. Um, when the vapor pressure of a liquid is equal to the external pressure. Um, I don't know. What is vapor pressure? It is the pressure above a boiling liquid, uh, above an equilibrated boiling liquid. Oh, what is reaction coupling? Coupling two reactions so that the overall reaction is spontaneous. It doesn't. Thermodynamics and kinetics are separate. What is a spontaneous reaction? It's a reaction that happens naturally. It is negative delta G. What is the difference between evaporation and boiling? And boiling, evaporation happens naturally at the surface level. It's not boiling point dependent. Boiling obviously is boiling point dependent. It happens throughout the entire liquid and does form bubbles. What is a phase diagram? Phase diagram, it just graphs the energy or temperature required, or the like, yeah, the graphs are it graphs versus time, kind of like the phases of the gas part or of the particles of the like substance. The graph showing different phases of something at varying pressures and temperatures. What happens when the vapor pressure is equal to external pressure on the liquid? It starts to boil. What is vapor pressure? It is the pressure above a liquid, above the pressure that exists above an equilibrated, isolated liquid. What are the important points and lines of the phase diagram? Uh, no, there's the triple point and the critical point. I don't know. I don't know what either one of those are. Okay, so I'm sitting there drawing fucking the titration curve for this. It looks nothing like a titration curve. Um, triple point is like, I don't know, like you might have an equal amount of solid, liquid, and gas, or something like that. What is what does the triple point represent? Yeah, okay. That's pretty much what I said. Um, Let me look up what the critical point is. It might low key ask me in this. If it asks me in this, well, I don't know. But let me just check if it asks. Because if it asks, I'm just doing this for nothing. It does ask. Okay. What is a phase diagram? It is a graph showing uh, the phases of a liquid at varying temperatures and pressure. What is standard temperature and pressure? 298, no, 273 K and 1 atm. Describe the phases. They all exist in equilibrium. What does it mean if a thermodynamic property is written with a degree sign? It means that that's the property in standard conditions. What is the triple point? The triple point is that's when all of the states exist, and they exist in equal amounts, I think. Well, they are in equilibrium. Okay. What is the critical point? I don't know. Boundary of pressure and temperature where you still see normal phases. What is unique about the phase diagram for water? Um, and the phase, it's something about the densities, like it's something about the density of gas and of liquid and gas. Negative slope. There's a negative slope for the solid. Negative slope for the solid liquid equilibrium line. Most only have positive slopes. So you have the solid liquid equilibrium line, liquid I guess solid liquid, solid gas, and gas liquid equilibrium lines, as well as the critical point and triple point. What is the triple point? The triple point is uh hmm. The triple point is when all the phases exist in equilibrium. Critical point is the boundary of pressure and temperature, um, where like all phases can still exist. Above that, it becomes supercritical fluid with gaseous and liquid properties. What is a substance standard state? It's its state in standard conditions. What is unique about the phase diagram? It has a negative slope for the solid liquid. equilibrium line. What is heat? Um, Energy. Transfer of energy between two things by virtue of temperature difference. What is the difference between heat and enthalpy? Does it explain what a state function is? Because define H as a state function. State functions bro, in school they always mess with me, bro. I can never figure it out. Describe H. Let me see if it says what a state function is. It does not, in fact, say what a state function is. We're gonna go through. Oh my god, I'm looking at these at the cards that we have coming up. Let me just say. Oh no, never mind. Never mind. I'm bugging. Okay. Um. We're about to hit 50 cards, which is not bad. We have like 48 minutes or so. What is the difference between heat and enthalpy? Um, what is the difference between heat and enthalpy? So heat is energy transfer due to temperature difference. Enthalpy is um, I guess energy. No, it's heat was energy transfer due to temperature difference. I don't know why I said heat transfer, but enthalpy is enthalpy is going to be the heat content at a constant temperature. What what are state functions? A property of a system that depends only on its current state, meaning temperature, pressure, and volume. A state function means that it doesn't matter how the system arrived there. Sorry, I'm trying to read what a state function is. This is like a very, very in-depth explanation. Uh, I'm trying to see if I can understand it. Okay. This is a very good definition. So basically, it said that a state function. I read like a much longer explanation, and I feel like it gave me a much longer explanation, but it was much worse. Um. So basically, it said that heat is because heat is the amount of energy transferred. You can't exactly say like, oh, this has X heat. This has X heat because heat is the amount of energy transferred. Um, so as a result, it's path dependent. So it depends on what came before it, right? Um, like if it was ice before, and now you used if it was ice before, and now it's a liquid, you would be able to find out the heat, but only because you knew what it was before. Um, you would need to know the initial state and the end state. So it's not a state function. It's very much path dependent. Enthalpy, on the other hand, because it's a total heat content, this is measurable. Like you can check it, and it doesn't matter what came before it. So it's a state function. It's path independent. It doesn't matter how it got there. All that matters for this value is the value that it is now. Delta H delta H, heat exchanged at a constant temperature, then I'm assuming that would be like, hold up, heat versus delta H. Okay, now I'm confused again because why is delta H a state function? Hold up. So basically, it said that delta H requires figuring out delta H requires normal H, and because normal H is a state function, delta H also has to be a state function. Heat is not a state function because it still just requires it requires you to know the path of like the previous states. Um, Honestly, that's not a much like that's not even a great definition in and of itself. But as I'm sure you guys have seen me do a lot of times, if you guys already understand this, then probably pretty easy to skip over this part. Uh, but yeah, I'm not really understanding this completely either. I'm just gonna memorize the definitions and call it a day. Okay, so heat is gonna be energy transferred due to a temperature difference. Enthalpy is gonna be um the total heat content at constant temperature, and then obviously change delta H is going to be the change in heat content at a constant temperature. As temperature increases, vapor pressure also increases. I know when my like when I took a long time to figure something out when my controller literally turns itself off. It like gives up sometimes. What happens when the vapor pressure of a liquid is equal to external? It starts to boil. What is vapor pressure? Vapor pressure is the pressure of the gas of molecules above a liquid um, when it's in an isolated, equilibrated state. Um, what is heat? Um, Heat is the energy transfer that occurs due to temperature, due to differences in temperature. What are the standard conditions? To 298 Kelvin or 25 degrees Celsius. Um, then 1 molar and 1 atm. Oh, my controller did not in fact give up. It actually died. Okay, all right, hold up. Let's see. Has it only been? I thought it. Not bugging. Oh, I see. I think I said a different time earlier. So I said I was gonna end at 9 p.m. But I also said that I was like calculating for ending at 3 hours. So they're like different. They're like different times. Yeah, we can end at 9. Because I do want to finish as much as possible here. Uh oh, that's not what I was. I like started this. I don't know why I did that. Um, uh, I need to connect my controller. Okay, there we go. Okay, all right, we're good now. Uh, what are the conditions for measuring equilibrium? I think I already said all these. Okay. What is standard temperature and pressure? 273 Kelvin and 1 atm. What is a phase diagram? It graphs the phases of a substance. Um, at varying pressures and temperatures. It doesn't. Um, what is the difference between evaporation and boiling? Evaporation occurs at the surface level, is not boiling point dependent, doesn't create bubbles. It's a natural conversion from a liquid to a gas. Boiling distributes the heat throughout the entire thing. It is boiling point dependent. And it obviously causes bubbling. What is the triple point? The triple point is the point at which gas, solid, and liquid all exists at equilibrium. The critical point is the point at which you still see the substance in its normal phases. Beyond that, you start to see supercritical fluid with gaseous and liquid properties. What is unique about the solid liquid phase line, like equilibrium line, is has a negative slope. What are the important points and lines? Solid liquid, solid gas, and liquid gas equilibrium lines, and the triple point and critical point. What is the difference between heat and enthalpy? Heat is the energy transferred between, um, I guess, two different substances uh, due to their temperature difference. Um, and then enthalpy is going to be of the total heat content of a substance at constant pressure. And then change in enthalpy is going to be the change in heat content at a constant temperature. Heat is going to be uh, um, so um, what is the difference between heat and enthalpy? Uh, yeah, I think so. Heat is going to be not a state function, and enthalpy is going to be a state function. What is heat? It is the energy transferred due to temperature differences. The process of measuring transferred heat is called um, calorimetry. There's like explosive TNT something, right? Oh, never mind. My fault. Just sworn there's I know there's one. I know there's one. I just don't know what it is. Constant pressure and constant volume. What is an example of a constant pressure calorimeter? Coffee cup. Coffee cup calorimeter. What is an example of a constant volume? You see? Bomb calorimeter, you see? Um, Vessel is rigid and volume does not change during the chemical reaction. What is the equation for the heat absorbed or released due to heat and temperature? Is this Q is equal to MC delta T? What is heat capacity? Um, this has specific like numbers. Heat capacity is equal to MC. Okay. What the process of measuring calorimetry? You have constant volume and constant pressure. What happens when two liquids at different temperatures mix? Um, they like average out. Their temperatures average out. What is an example of a constant pressure calorimeter? Um, Constant pressure. This is gonna be the coffee cup. I just don't understand it. Ah, I see. Okay. Um, what is an example of a constant volume calorimeter? Um, what is an example of a constant volume calorimeter? This is a bomb calorimeter, and the vessel is going to be rigid, so it keeps the volume. It keeps the volume constant. The equation for heat absorbed, Q is equal to mc delta T, where C is the specific heat capacity and M is the mass. What is heat capacity? MC, mass times the specific heat capacity. Oh, is it just called? Is it actually just specific heat? No, it is called the specific heat capacity. Okay, cool. Um, the energy is going to be spread out evenly throughout the mixture. So, um, obviously, depending on the specific heat capacity, then you're gonna have you're gonna cause a different change in temperature. What is an example of a constant pressure coffee cup calorimeter? What is a heating curve? Ah, you see, this I think was what I was thinking about. This is definitely what I was thinking about. I thought that the phase diagram was this. I was thinking of a heating curve. Temperature versus heat added. What happens when when the vapor pressure of a liquid is equal? It starts to boil. What is the enthalpy of fusion? The energy, uh, well, the heat content necessary in order to melt a substance. Okay. What is vapor pressure? What is vapor pressure? Um, okay. What is vapor pressure? Vapor pressure is the pressure of gas molecules that exist um, above an isolated equilibrated liquid. Heat is going to be the energy transferred due to temperature difference. Enthalpy is going to be the total heat content. Um, uh, it's going to be the total heat content uh, at constant temperature, and obviously change in enthalpy is going to be the change in heat content at constant temperature, at constant pressure. I mean, heat is going to be not a state function, and enthalpy is a state function. A heating curve is a graph of temperature versus heat added, as well as like marking the like states and yeah. What are two types of constant volume and constant temperature? I mean, no, constant volume and constant pressure. Um, Calorimetry, uh, 273 Kelvin and 1 ATM. The heat, the heat required to melt 1 mole of a substance at constant pressure without changing the temperature. A phase diagram, it's a graph of temperature and a graph like marking the different phases of a liquid. I mean, not a liquid, of a substance at varying temperatures and pressures. Um, what is the critical point? The critical point is the boundary of temperature and pressure for a substance where beyond that temperature and pressure, it becomes a supercritical fluid with liquid and gaseous properties. I still think that's right. It means that gas, at that point, gas, solid, and liquid all exist in equilibrium. What is unique about the phase diagram for water? Um, there's a negative slope for a negative slope, a negative slope for the solid liquid equilibrium line. A constant volume is the bomb calorimeter, which is the vessel is rigid, so it's obviously has a constant volume. What is heat? Heat is the energy transferred due to temperature difference. What happens when two liquids at different temperatures mix? The energy between the liquids is gonna average out. What is heat capacity? Is going to be M times C. What is the enthalpy of vaporization? It's going to be like, I'm just going to base it off of the other one. It's going to be the heat required to convert 1 mole of liquid to gas at constant temperature without changing at constant pressure without changing the temperature. Oh, this one doesn't have the long complicated explanation. This one's gonna be inaccurate now. I'm gonna check. I'm gonna check the card because bro, it lied to me for the enthalpy of for enthalpy of fusion. I just changed the other definition. It doesn't have to do with the mole unless you're talking about the standard. I don't know why it didn't. Why it said 1 mole if it didn't even bring that up. Uh, okay. It's gonna be. This is gonna be the same thing, bro. I'm just gonna change it because I'm just gonna change it to the other one because what is the equation required? Q equals MC delta T. What is a heating curve? A heating curve is uh, it graphs temperature versus a graph of temperature versus heat for a specific substance. I mean, of temperature versus heat added. Yeah, I think so. Temperature versus heat added. How can we find the enthalpy of a reaction? Um, uh, what is the standard enthalpy of formation? This is the heat required to um, to go from solid to gas. The heat required to go from solid to gas uh, at constant pressure and without changing temperature. Constant pressure is a coffee cup calorimeter. It uses the outside pressure. What is the standard enthalpy of formation of something already in a standard state? Um, It's the energy required to, or the heat required to, to, I don't know, bro. How can we find the enthalpy of a reaction? The enthalpy of the reactants minus the products. Oh man. What is the standard enthalpy of formation? Um, what is this difference between heat and enthalpy? Heat is gonna be the let's see. Let's see this. At, in like 10 minutes, like 10 minutes, I'm gonna turn off reviews. I mean, turn off new cards. What is the difference between heat and enthalpy? Um, okay, very cool. What is the difference between heat and enthalpy? Heat is going to be the energy transfer due to temperature difference. Enthalpy is going to be the total heat content. Um, Total heat content at constant temperature. Um, we need a change in heat content at constant pressure. Calorimetry. Standard enthalpy of formation of something, 0. How can we find the enthalpy of a reaction? Um, uh, the enthalpy of the products minus the reactants. What is the standard enthalpy of formation? Um, the enthalpy of the products in there, of the products minus the enthalpy of the reactants in their standard states. Oh man, hold on. Enthalpy of formation formula. Oh, I think enthalpy of formation is just given to you. I don't think they ever. Okay. Enthalpy to produce 1 mole. What are the two types of calorimetry? Constant volume and constant pressure. Enthalpy of vaporization. That is the heat required to convert liquid into gas at constant pressure without changing the temperature. What is a heating curve? It's a graph of temperature versus heat added. a bomb calorimeter, um, the enthalpy of the products minus the reactants. Oh, what is Hess's law? The overall enthalpy of a stepwise reaction series is equal to the sum of each step. What is heat capacity is equal to mass times the specific heat capacity. What is the standard enthalpy of formation? It is the heat required to form 1 mole of a compound from the elements in their standard states. What happened to the energies average out? How can we calculate the standard enthalpy of a reaction? Um, you would do the standard enthalpy of formations of the products minus standard enthalpy of formation of the reactants. What is Hess's law? Hess's law is that um, Hess's law how far are we from finishing this? What is Hess's law? It says that the sum of stepwise the sum of stepwise reaction is equal to the enthalpy of the overall reaction. The sum of the enthalpy of each of the stepwise reactions is equal to the enthalpy of the overall reaction. How does Hess's law only apply to enthalpy? Um, no. What is the standard enthalpy of formation of something already in a standard state? Um, 0. How does one find the overall enthalpy of a multi-step reaction? You add up all of them. Add up the enthalpy of all the steps. Um, this like this is like not descriptive at all. You're basically gonna try to cancel everything out though, to be honest. I can kind of like, based off of this description, I think I can figure it out. Okay. We have reached the point where I turn off new cards. We were able to get through 64 cards in 3 hours. Zero new cards. All right. Um, how can we find the enthalpy of a reaction? Um, how can we find the enthalpy of a reaction? The enthalpy of the products minus enthalpy of the reactants. No, it applies to all state functions. What is the enthalpy of fusion? What is the enthalpy of fusion? Enthalpy of fusion is uh, the heat required to convert solid to gas at constant pressure and without changing the temperature. Uh, you just need to like flip, like you have the steps. You're basically just gonna try to line up the ones in between so that you're able to replace things. It's kind of like physics equations. You just want to be able to replace things where they go. If you flip a reaction, you need to make sure to flip the sign of the enthalpy as well. Um, and basically, your goal is to just end up with the first and last step. What is the standard enthalpy of formation? What is the standard enthalpy of formation? Enthalpy required to form 1 mole of a substance, 1 mole of a compound from their standard states, from the elements in their standard state. How can we calculate the standard enthalpy of a reaction? Um, it's going to be delta. What's it called? Delta. Um, or standard enthalpy of a reaction. Um, how can we calculate the standard enthalpy of a reaction? Uh, you're gonna put the standard enthalpy of formation of the products minus the standard enthalpy of formation of the reactants. What is Hess's law? The sum of the individual steps of a reaction is equal to the enthalpy of the overall reaction. What is enthalpy of vaporization? The heat required to convert liquid to gas with constant pressure and without changing the temperature. If it says 6 days, that means you just need to do that again, bro. What is a heating curve? It graphs temperature versus heat added. Does Hess's law only apply to enthalpy? Um, Does Hess's law only apply to enthalpy? Uh, does Hess's law only apply to enthalpy? No, it applies to all state functions. How does one find the overall enthalpy of a multi-step reaction? You just need to add them up, manipulate the reactions, do all that stuff. What is the standard enthalpy of formation of something already? Zero. How do we find the enthalpy of a reaction? Enthalpy of the products minus enthalpy of the reactants. What is the standard enthalpy of formation? It is the enthalpy to produce 1 mole of a compound from the elements in their standard state. What is Hess's law? The sum of the individual steps is equal to sum of the enthalpy of the individual steps is equal to the is equal to the enthalpy of the overall reaction. How do we calculate the standard enthalpy of a reaction? The standard enthalpy of formation um, of the products minus the reactants. What is the enthalpy of vaporization of the heat required to convert liquid into gas at constant pressure without changing temperature? No, it applies to all state functions. Manipulation, bro. That's how you do it. All right. 31%. We're at 31% now. I don't know what we started off. Let's see. Let's check what we started off with. I think I checked early on, if I'm not mistaken. Like very early on. Yeah, I did. Here it is. Um, Let me see. I think I can't. I went exactly to the point. So we were done. We were done 30%. We went up by 1%, which is, hey man, better than nothing. But yeah, so we will continue this tomorrow. Maybe tomorrow we can get a little further. We can probably. I hope that we can finish chemistry deck by tomorrow. If not, then obviously I guess that's fine. But anyways, thank you everyone for watching, and I hope you guys have a nice rest of your day. And goodbye.